So I think you're keen on learning more about gRPC, right? So let's talk about gRPC. You'll get the source code and the slides. I will send those to Daniel, and he can put them on the meetup. So if you want to execute the code yourself, you will be able to do that. So my name is Irina. I'm from Romania. So in here it's 8 o'clock, 8:30 o'clock, 2 hours difference. I'm a Microsoft MVP. I work at a company named Endava that's headquartered in UK. You can find me on Twitter at that handle. I blog, not as often as I would love to blog because I don't have so much time at my disposition, but I'm trying to keep a constant with that once per month. It's good enough. Cool. Also, what I did lately was to make, together with Nick Chapsas, Dome Trains, a course in gRPC from zero to hero. So you'll find there about 4 hours with everything gRPC. So if you would like to go more in depth. And also during my pregnancy leave, maternal leave, I wrote this. So if you know anyone that wants to move and learn about web API or web in general, that might be the book. So now to our story. So who here? Because I organize a user group today, due to the scheduling, I jumped from Zoom call to another Zoom call. So I had my own user group meetup that where the presenter spoke about the modular monolith, which led me to think that, well, to be fair, I kind of loved monoliths. And during my early days with development, the monoliths were a thing that was everywhere. I used to develop ASP web forms with code written in Visual Basic.net or ASP MVC, the first version. So everything that we had back then was not a modular monolith, but a monolith. And I fairly enjoyed working with those type of systems because, let's be fair, everything was self-contained. If we ever needed something, it was in the code base there, in one code base. So I'm going to ask you, just raise your hand or something like that. Who here loves the monoliths? And I'm going to be to blame. I love monoliths. So not that I'm against modern standards or modern architectures like microservices and nanoservices and stuff like that. But the life was easy with monoliths for us developers. And you have to admit it. So it was easy to start. It was easy to onboard. If you have a junior developer or a new hire that wanted to, well, work. So everything was in there. So you didn't have to worry about things like where is that API or the other API, or to make this run, you would have to make another 10 things run. So it was very nice. But the problem with this monolith was that it was hard to scale. I mean, it was scalable, but the cost that you paid to scale these might not justify with the business owners. So it was a bad user experience because also you got that all or nothing deploys. So either everything worked or didn't work. So black and white, no in-betweens. So that was the things with the monoliths. So basically back then we had architectures like this. We had front end, we had back end in one code base. And usually that code base was a mono repo. Okay. So when things started to evolve, when storage became cheaper to buy, we realized that, well, we can split this. And now we got front end, purely front end apps, and we got backends. And those backends had a database or integration with a third party or several databases, depending on the scenario. But we realized that REST or RESTful APIs were a thing, and we started slowly to decouple. So we all know that the future is kind of distributed, and we realized that, now we can have a front-end app written in whatever JS that consumes data from several APIs, several backends, And back in the back of those backends, we could have one database or another backend. And in the app, we might have something like this, like those polyglot or wannabe polyglot systems that we all spoke about, but no one saw them. So once we started to realize that, well, our system might be better if it was decoupled. Now we might have components in our system that it's worth to be written in Node.js or in Go. And we might have third-party APIs that were written in Java and stuff like that. And everything that was common between all these technologies was JSON. And to consume JSON, we basically said that we have REST APIs. Okay. So now we have REST for everything. REST is kind of the de facto standard. So I will ask you, who here implemented or has wrote a REST API before? Here. Thank you, Rob, for answering. Okay. Who here really wrote a REST API, like respecting all the guidelines or everything that was mentioned? Hypermedia, types. Who here? Hands up. Hands down, Stefan, right? Hands down. Same. So basically, we cherry pick the things that we considered to be good for us. We didn't care about hate OS or anything that, I don't know, was for us not useful. So, or we said that if we add links in our responses, that would add overhead, and we do not afford to have overhead and stuff like that. So basically, one thing that REST did good was to force us in a way to use the HTTP verbs as those HTTP verbs should be used, right? So that's a plus. So what's wrong with REST? So it's nothing wrong with REST, but we kind of use it everywhere. But since we use it everywhere, we have to be aware that there are other technologies out there that we could use, not REST or JSON over HTTP as we all develop, right? So because we're not developing REST, we're doing JSON over an HTTP protocol that it's sent to whatever consumers we have. So here goes remote procedure calls. Remote procedure calls, it's a concept that has been around since the 70s, so it's not new. So you see the tendency of certain concepts to resurface from time to time. So an RPC as a concept will make the system behave like, will make a distributed system, basically, behave as if it's part of the same code base or the same structure of the monolith. So an RPC, if we look here at this code, basically what we have an order that is obtained by calling a create order and passing in an order request. And then we have a payment status that is obtained by calling a process payment for. And then if the payment is successful, we might arrange the shipping for that specific order. Nothing fancy, nothing complicated. Besides the naming, sales, bounded context, everything is like it's in the same system, right? In the same code base. You are able to call methods. Everything is method, right? So you don't have HTTP requests, you have methods that you call, right? So if we look here, we have the payment status that comes as a response from process payment for that order. Basically, there is a hope over the network. But as developer, we might not be aware because RPC as a concept in its whole will make the code look local. We call methods. We do not call endpoints. We call methods by using method calls. So it's prone to errors due to that fact. But the goal of the RPC concept is to make the network communication transparent and make your system behave as if it's only one. Okay, so People thought, we have now distribution, we have components all over the network. What if this distributed system would behave like a monolith? Woo, good job. Here comes RPC, right? So, in fact, what is this gRPC? So, gRPC started in 2001 as a Google internal project named Stubby. And in 2005, they open sourced it. And fast forwarding a few years, we got it in .NET around 2019 with .NET Core. So since then, we were able to create a special project type by using Visual Studio or the preferred IDE that is called gRPC service. And since then, a whole new world opened for us, another technology that we need to be aware of. So gRPC as a concept is contract-based. We have no more code references. Remember that with HTTP APIs, I'm going to make a parenthesis here and I'm going to tell you a story. So during my work as an architect, I work with different teams. And some of these teams realize that, we have to have data from one service to another service. How do we obtain those? Well, the first thing that comes to mind is to make an HTTP call using an HTTP client. Yeah. So they started to create HTTP clients to make call to that specific service. And then as the system evolved, they realized that, cool, we have this kind of call that is needed here too. What do? Well, we pack that HTTP client into a NuGet package and we distribute it. So when whoever wants to use that HTTP client will just use that package and it will be able to create a new client to get data from that specific service. So nothing bad so far. But what happened after a while is that those bare bone HTTP clients started to get some business logic in there. So now we share the business logic everywhere with those NuGet packages. So that's bad for business, right? So with gRPC, no one will be able to add a NuGet package reference and to share and to make spaghetti code, okay? So I will show you, I have a lot of code to show you, but gRPC uses HTTP2, which is inherently faster due to the fact that how it's built. It uses another kind of serialization that ends up having a smaller payload because it's named protobuf and it's binary, okay? And it's available in many languages. And being available in many languages, we will also get this code generation. So if we have a gRPC service that is written as a business logic in C#, now we could obtain the same business logic in a way written in Go or in Node.js. So now we could have .NET consuming Node.js and vice versa without doing too many changes because we have this code generation. So now when we're talking client request architecture, so we have a client, we have a server, in between, we will have something that is called a protofile. And this protofile is neither written in C#, neither in Java. It's, let's say, a special language named protocol buffers that is defined by Google, which we will use to make that interoperability possible. So this protofile, it's like this. We have the syntax version that we will have to specify. And then we will have to specify if we're using C#, which is the namespace under which we will find our service. And then we will specify which is the package for this. And then we will have to define what we expose. If with REST we expose endpoints, in here we expose operations. So now we will have a service named Fibo that exposes an operation like a method of type RPC, which is named compute Fibonacci, and it has, sorry about that, and it has a requested number as a parameter and returns a Fibonacci result as an output, as a result, basically. The deal with this kind of operation is that you cannot have void here. You have to have something passed in, even though that type is empty. You'll have to pass something in there. And also you'll have to define and specify this. So further along the road, you will define also the types that will get transformed to C# classes in our case, or in Java or in Node.js or whatever types. But these types have the keyword message and have a type. And inside the type, you can define properties. Don't be fooled. This int32 number equals 1. This is not an assignment. This is the order in the by string of this property. So if you have several of those, you will have to equal 2 and something like that. Okay, so you simply define types that become C# classes, and you put these types as inputs and outputs for your operations. Okay, so once you did this, you will have to look and see what other types are available in gRPC. So gRPC is very powerful due to the fact that it allows you to define these operations and types inside the protocol buffers file. And then you'll be able to tell inside the same definition how the method will behave. So we have 4 methods or modes that work with HTTP2 protocol. So the first one is unary. In the unary type, the client will initiate a request to the gRPC service. The gRPC service receives that request and responds back. It's a typical request response as we know from HTTP, if we were to make such a mapping. How we define such an operation? Simply by defining the name, the input type, and the return type. So in here, we have an input and an output. So it's 1 and 1 out. For the next one, the server streaming, the client will need to issue a request. So it will open up a communication channel. But the server, once it receives that request, it will answer with several chunks of data. So to define such kind of operation, you'll simply add the stream keyword near the part that it's streaming. Yeah, so this works to the fact how the HTTP2 protocol works. You are able to send several chunks of data from the server to the client. So the next part is the client streaming, which works kind of in reverse. The client will open a communication channel to the server, and it will send several chunks of data, and the server will respond with 1 chunk back. So if we look here, we have 1 as one part that streams. This is the part that has a stream of parameters, and it will get back 1 single result. So we will have here many things in and 1 single thing out. Okay? Bi-directional streaming, well, the previous 2 combined. The client opens up a communication channel, sends several chunks of data, and the servers respond with several chunks of data. Okay? So the power of this comes from the fact that there isn't several HTTP connections opened. So these 2 parties, like the client and the server, can communicate over the same TCP connection. So imagine a thing where the client will send, I don't know, data to the server, like uploading chunks, a big file that is chunked, and it uploads to the server. So now, over a single TCP connection, the client can send those chunks of data without opening a new connection for each chunk. Okay, so this speeds up the process, basically. So one thing that comes to mind when it comes to gRPC, I'm going to show you some code right away. In fact, I should do that now. So you should be able to see my Visual Studio right now. So I'm going to close this and maximize. So just to start, I'm going to zoom in. We have here gRPC service 1. I updated it to .NET version 8. So I have this. It's if you look at this project, it's nothing fancy. You'll see things that you automatically recognize. You have program CS, appsetting.json. But in this type of project, you won't find any controllers, you won't find any models. Instead, you'll find this protocol files, protos folder with the proto file. And inside here, you'll see that you have the same syntax that I specified in the slide. So you have the syntax, the namespace that you want to use, the service that you want to expose, and the operation that you want to expose here, and two types. I think this is better. So, and two types. Say hello has a hello request as an input parameter and returns a hello reply as an output parameter. So it will be one in, one out. These two types are C# classes that you will be able to use whenever the server is running. So I think this is it about the service implementation. So once you have this definition, you'll be able to create an actual logic, a C# class that implements those methods. So you'll have there, like you create a class named greeterService that extends the base class. And if we look at this base class, you'll see that it has some funky code. This is the code generation part that I mentioned about. So you'll see that it's a static partial class named greeter with some funky looking code that is specified here. Do not edit. So use it as it is because it's automatically generated by the protocol buffers compiler. Okay, so in here, once you basically extend the base class, you'll be able to go in here and say, hey, public override, and give your own implementation. So I'm going to Control X in here just to, you see you have the say hello that is specifying the base class, and you'll be able to override it and to provide your own logic. So this is how gRPC basically works. It gives you a base class that is static and stuff like that, and you'll be able to override to provide logic. So if this is a unary method, so it has one single parameter, and it was one single return parameter, and the logic, the business logic, basically it's up to you, okay? One thing that I want you to notice here is that for every single method that you will override from the base class to provide business logic, you'll have a second one that you'll need to mock whenever you do tests. This is server call context that is similar to what you will find with HTTP API, HTTP context. But this is one level beneath that HTTP context. So if we ever find yourself in the position of, I don't know, needing things like the real HTTP context, you can call a method from there, and you'll be able to access the object that you're familiar with. HTTP context from ASP.NET Core that we all know of. Okay, so this is the service part. And in the program CS, you'll notice that there is a middleware enabled named @gRPC. And then a service mapped here, map gRPC service, and you simply pass in the service that you need to map in here. So basically, this is it. It's a template. You'll notice that it has no funky packages. It's only ASP.NET Core, that version that is in there. That's the only thing that it is. So this is the basic of a gRPC service. But let's see it in action. In the source code, you'll find a server because, well, it's an API and it needs to run in order to respond with data. So this server is a gRPC type of project that has a protocol buffers file that has all methods defined. So it's a greeter. It has one request, returns one response, server stream, client stream, and bi-directional. You'll see that on the part that streams, we will have the keyword stream. And in here, in the services, you have the greeter service that implements all the four methods. So if we look at the unary one, it's say hello. It has a request as a parameter. This is nothing more than a type. If I'm going to F12 in it, you'll see that it's still funky looking because it's generated by the protocol buffers compiler. I'm going to close this in. So in here we have some business logic, which is not that logic. We have the request that has a property named content value that we're basically passing in as a string, and also writing it the host from where it comes. Okay, so this is the server implementation. Let's look at the client, and inside the client you'll have a folder named unary with the console app. So the console app is the easiest way of consuming a gRPC for demo purposes. So you'll notice here that we have a program CS. And if we look at the dependency part, you'll see that there is no reference to our server. I told you that with gRPC, there will be no mod code references, no packages that depend on other packages, other class library and stuff like that. But what we have is these gRPC related libraries. One of them is gRPC Net Client Factory that allows us to instantiate gRPC clients. gRPC tools is very important because it allows you to reference the protocol buffers files. And I'm going to show you just right away. So if we look here, you'll see a funky folder link like. And if we expand the grid proto, you'll see that the content of it is the same content that we find inside our server. It's basically a reference, kinda, a virtual folder, a virtual reference to our initial file. So do not edit this. So what we can do to make our console app run as if it's referencing the server is to edit the project file and add a node. So that node is this, is an item group of type protobuf, and you simply go and create the path up until you find the protocol file that you need. So inside our unary project, which is here, we browse so many levels above until we find this file. So when we find this file, say, okay, cool, this is the protocol file that I need. And I want it to behave like a client, because this current project will be the client of our server. And another thing that will happen is by using this link, and you're going to specify which is the link of this protocol buffer file. So if you're using a JetBrains writer, you will have to add this by hand. Like, go there and browse and find the file that you want. This allows you the flexibility to make sure that the protocol buffers stay maybe in a separate repository. And that's a cool thing. You have a separate repository where you have your protocol buffers file, and you have like one source of truth. You do not scatter them everywhere. Okay? So this is one. So if I open the server project file, you'll see that we find a similar item group that points to our protocol buffers file, where the attribute is gRPC services equaling server. So it's not client anymore. So this is one of the tips and tricks. If you're using Visual Studio, and I want to show you this because I struggled for a bit with it. If you right-click the project and you click Add, you find here Connected Service. So this is only in Visual Studio. So in here, you'll find, I'm going to zoom in a bit. Hopefully, I'm going to zoom in. Hey, doesn't want, okay, cool. You have here service references of type OpenAPI, gRPC, and WCF. If you click the plus sign, it will open up this wizard where you will be able to select gRPC, click next, and go ahead and browse the file that you need. So for example, I want to use this protocol buffers file. And when you click open, you select here what type of client, what type you want generated. You want client and server, you want only the types to be generated, or client and server. I'm going to select client. And when I click finish, the thing that will happen here is it will install all the packages needed automatically without you thinking, why do I need this? Do I need this or this or this? It will automatically install these 4 packages, and it will basically um, streamline all the process. But this is only in Visual Studio. I will have to check JetBrains Rider to see if they fixed it or not. But keep in mind that this is an option. It wasn't there in 2019 when they add the gRPC, so it's a lifesaver. Cool. So once we have this, we'll be able to go inside the code because that's what we want to see. And inside the code, we'll be able to say, hey, you know what? I want to create a channel, like a communication channel at this specific address. So notice here, you will need to know which is the server address. And of course, you will have to have the server running. And for that, I want to create a client and pass in that specific channel. Okay, so once you get the channel, you'll be able to call the methods that are implemented in that specific server. So if I add here client dot, you'll see that we get all the messages, all the methods that we define in our protocol buffers file. And this is happening just because we pointed to our protocol buffers file. So we didn't add the code references, we didn't reference the server itself, but we told this project where it will find the definition for our services with our methods and types. So once you add that, you'll be able to pass in the request and obtain a response back. So let's run this. I will have here, I'm gonna zoom and clear this a bit. This is a console that points to the server instance that I'm gonna run. So it's building the console, the project, and you'll see that it's listening at this specific port. And on the right-hand side, I have a similar approach where I'm pointing to the unary console project. So I'm gonna do .NET run. And you'll see that I'm sending hello Sheffield, and I get hello back with hello Sheffield value from localhost 5000 port server. So that's the port of the server that answered. Okay, put the R back to have complete. Okay, it has a point. I'm going to show you a demo. So if we look on the server part, you'll see that we got some things like executing endpoint of greeter, say hello method, and starting to receive a call. I got hello Sheffield, and then the request finished with HTTP2. It's a post request. So with gRPC, you cannot do other types of requests. You cannot use other types of verbs. Everything gets post. So you don't have get, you don't have delete, update, patch, or anything that's around it. Everything gets post. This is the quote unquote endpoint. So this is the method that it's called. It comes back with 200 as a status code. Is of type application gRPC. So this is the MIME type. Okay. So this happens for the unary one. For the client streaming, I'm gonna use the same, but first I'm gonna show you the code. So for the client streaming, it's still a console app that calls in for the server. It creates a client, and by using the client stream, it loops to this value and writes writes things in the request stream. So it writes the I stringified, and then it awaits for the request stream to be completed, and by the end, it listens the response. So let's see it in practice. So client streaming, it says that supposedly it will send several things to the server. So it's a .NET run. I'm gonna wait and see what's happening on the server side. I'm gonna run it again. So on the left-hand side, you see that things are moving, matrix types like. So the server said, I got a request with content value. This is the property in the request type, and this is the I increased. So several things to the server, and the client got only one response. So this is the client streaming. And this is the index, the last value of the index that the server received. Client streaming. Server streaming is pretty much on the same pattern. So we have the same gRPC channel pointing to the specific address. We obtain a client, and I have to make a short parenthesis here. This greeter client I didn't wrote. It's part of that code generation that comes with gRPC. It generates two things, and I'm going to show you those things. So you will find the generated code just in case something bad happens. So if we expand the server, under object debug, the version of .NET that you have, you'll have a Protos folder. And inside that Protos folder, you'll have two C# classes. So you can do an exercise. You can also run the protocol buffers compiler by yourself by using a simply protocol file that you pass in as a parameter, and you tell it, hey, generate this. And these are the classes that are generated. So by using reflection and funky code. But this is the code that we can use. Service name is greeter, the namespace, and stuff like that. Part of this funky code is that client that we are able to use inside our consumers, basically to obtain channels and use them and reuse them. One thing that is a good practice is once you create a channel, so like a communication channel, a TCP connection with that specific server, keep it open. You have ways to query if the connection is open or not. But once you create a client, make sure that you reuse the client or instantiate several clients by using the same channel, because it will reuse the same connection. Another thing that is really worth mentioning is that with your requests, you can pass parameters like cancellation tokens. So you can pass tokens, or you can also pass deadlines. I have this commented so you can execute it yourself. So for example, you can say that, hey, if I do not get a response in this amount of time, 1 millisecond, kill the request itself. I don't need it anymore. So this way you can prevent requests from hanging in there, but the server not being available. So how the server streaming works is simply create a request stream, send in one single request, and wait for all the chunks of data from the response stream to be sent. And when those are sent, simply write those in the console, in our case, of course. So server should be up and running and listening. And if we run the server streaming, which is this, .NET run, you see now that the server is sending several things to our client. The same pattern, an I that gets increased. So with this, we're going to pass to the next example, the bi-directional one, which is a combination of the previous two. Whoa! Cannot find the bi-directional. No wonder. .NET run. So I'm sending an I that goes to 10, and I get back 10 values, basically. So don't be fooled, the order is not guaranteed. It just happened to be like that. But what I want you to observe is that I'm sending 10 things and I receive 10 things. So over a single connection, these things go back and forth. And it takes a super small amount of time. Cool. So these are the 4 modes that might come handy if you're using this. But this is not all the power that gRPC has. gRPC has some internal things that we need to talk about. And those things are first related to the status codes. So we all know status codes. Those are linked to HTTP protocol. There are like, I don't know how many, 60 status codes, like 404, 200, 101, 401, and stuff like that. So those sit at the protocol level. But when it comes to gRPC, since we are one level below the protocol level, we do not have access to those. I mean, we have, but we have access to like several 200 that you actually see it in action. I think 404 bad request, I think, that comes by itself if something bad happens. But you see here 200, this is the HTTP protocol level status code. But when it comes to status codes in gRPC, to the smaller requests and responses, we have an enumeration that has 16 values that it's not mappable, if that's a word, to our existing status codes that we all are familiar with. So we have data loss, cancel, deadline exceeded, invalid argument, okay, out of range, unauthenticated, might be, unimplemented, unknown. Yeah, so how do we know what happened inside our small gRPC request? Well, super simple. We look at an RPC exception, which, by the way, is the sole exception that we'll find with gRPC. So we have this RPC exception. And if we're interested in a specific status code of our call, we filter it by status code property that sits on the exception type. So this way we can do a thing like, okay, I'm going to set this. I'm going to comment this out and show you. So I have a cancellation token source, 5 seconds, but I also have a deadline of 1 millisecond. And I'm going to catch this exception when deadline is exceeded. And I know that deadline property will cause the deadline exceeded when I run it. So now if my server is up and running, I'm going to go to this, which is this server streaming. And I'm going to run the console again. Whoops. And I get this. Whoops, your greetings timed out. So my greetings timed out because I added this deadline property and I caught this exception. Hey, when this happens, an exception is thrown, look at the status code that it sits in there and write this to the console. So this is how it happens. So one thing that I want to emphasize is that with gRPC, we have the HTTP protocol, and underneath the HTTP protocol, we have the small gRPC calls. Those small gRPC calls are like independent, and they need to have their own status codes and their own mind, basically, because they travel below what we know. Okay, so this is one way of identifying what happened with that small thing that sits below the HTTP protocol. So another thing is related to RPC exception. Request headers and response headers and response trailers. So since we know that gRPC has some other status codes, an enum that we have to pick from, a different story happens with the headers too. So now we have the headers that sit at the HTTP protocol level. Those are there, will be there. But sometimes we might need to send something per individual gRPC request. And we had no way of doing that without altering the protocol level ones that is generic. And those are sent only after all our gRPC request responses came back and finished at the end. So in order to help us send small things that don't fit in the request of gRPC body, they invented a thing that is called header trailer. So we have, I'm going to show you better in another example. So here it is. Cool. So we have a way of adding a type that is called metadata entry, which is a dictionary where we can pass in a string as a key and another string as a value. And we can attach those to the response. The same happens when we want to read from the request that comes in gRPC. So you have a request value and you'll see the key and you'll obtain the value. So you can add what you get from the request back as a response. You can do what you want because the type that behaves like header for the individual gRPC request is nothing more than a dictionary that you can use, okay? And you can access those by using the context object that comes mandatory as the second parameter with, or the third with our calls. So this is how we can mimic basically headers for the response and for the request. So, for example, if we want to add something with the request, we will do something like this, and we will pass then as the call options. You have here headers, and you'll pass in these objects. So you can mimic those. And I don't know if you noticed, but in one of our calls, I think in here, we found this. Found some trailer values in the gRPC response, gRPC header. So this was a dictionary that I added in order to mimic an individual gRPC request or response header. We're using the same types, but it matters when you add it. So you added that key value pair when you do the gRPC request, or you add it before you send the response. So it matters in terms of the time, but the type that we use is the same in the both parts. Another thing that we can have with gRPC is to tweak some things, like we can add compression levels if we want. We can have we can configure maximum receive message size. So if we do not want, as a business logic or business constraint, to have gRPC requests that exceed 2 megabytes, we can configure that, or 5 megabytes or stuff like that. We can also have compression algorithms. Those might be important. Like we can have gzip, we can have compression providers, we can configure our own. So, and another thing that I just want to specify is related to interceptors. Interceptors are a rather similar concept to middlewares, but these work at gRPC level. So underneath the application, the protocol, and run only when gRPC calls happen. And the middlewares, as we all know from ASP.NET, happen at the global scale inside our application. So you can add those. Security related, everything that is possible with the web API, for example, it happens here. But we also have the flexibility to add authentication types at the channel level. So when we open the communication channel with the server, or at the connection level for individual gRPC requests. We can add things like claims. Everything is possible. One thing that is not possible is NTLM authentication with Windows. That would be possible with gRPC due to the fact of how HTTP2 works. But everything that I listed in here, JVT instead of token, so it's redundant there. We can have client certificates to add. We can work with Azure Active Directory, OAuth, OpenID, WS Federation. So everything that you're used to with APIs, you can add in here. So what gRPC should do awesome, and I have like 5 more minutes. So gRPC should do awesome a thing that is called gRPC transcoding. gRPC transcoding, it's a bit that allows us, it's a package that allows us to call gRPC services from the browser too. So it will make a sort of translation for us. And I'm gonna show you that too. So you have here a project named transcoding, where if you look inside, you'll see that is the same template implemented, the same logic that you'll be familiar with. You have the protocol buffer definition. But in here, you'll see that there's a folder structure with 2 additional protocol files. One is called annotations and one is called HTTP proto. So this allows us, when we import it in our protocol file, see, you can import proto files like you would do with LESS or SAS CSS files and stuff like that. So you can split your types inside the protocol files. So we import this, and once we import this, we can do a thing like this. You can say, hey, I have this method, this operation named say hello. It has an input named hello request and returns a hello reply. But I also want to expose this as a get method request in the browser under this specific path. So now I have the flexibility of doing internal calls with gRPC, so inside downstream APIs. But if I ever want to expose this as an external API, I can do it too by using the syntax get and specify here the endpoint. So I'm going to run this transcoding API to show you how it is. What startup project and how it runs. The deal is that it's not final, and you'll have to add this folder structure manually, so by yourself. So you'll have here a localhost. Hey, browser, where are you? This is the path. I'm going to open a new browser instance in here. So, hello. See, I get a message back. So this wasn't possible before. And you'll see here that it got the request finished. It passed into this specific endpoint. It is received as application JSON, but in fact, it calls my service endpoint. Yeah, so it's a transcoding, as the name says, translation in a way. So it gets JSON, it doesn't communicate end-to-end in gRPC with MIME type and stuff like that. It simply takes JSON, transforms it, and allows me to hit the endpoint and the gRPC service implementation that I have. So this is super powerful, but it's still at the beginning of development, so it might not be that stable. You can also expose this as different verbs, so you can have get, and these parameters will be bound from the URL. You could also have another thing like patch, and you can also have bodies. So you can expose basically the methods out to external consumers, not only to your downstream APIs. So this is one of the things. Another thing, it's related to client-side load balancing. So client-side load balancing will allow me to connect to a server. I'm going to run this extra gRPC because I'm running out of time. So, and then now it's late. So I'm going to copy paste the .NET run command. So I will run another server instance, and I will have it listen at this specific port. So one server up and the second server still up. And now whenever I'm going to run a specific client, supposedly .NET run, I will get back this port. And if I stop again and I run again, fingers crossed, I get it from the second server. This is very useful if you have like Kubernetes and you have to spin new pods and stuff like that. So you can configure policies, like you can have a round robin policy. You can have different types of resolver. You can be static, you can be DNS. You can pick first, round robin, or you can implement your own resolvers if you want. So how do you do that? Because that's the point. You do that by specifying a retry policy. Here. That's for you to have a look at. You specify a type of resolver, you pass in the address where your server lives, and you pass in when you create the channel. So the port address, this is localhost, this is simply a string. You'll have gRPC channel options. You can pass in the credentials if you have, and you should have, if you're running it in production. And inside the service config, you have this, where you configure if it's a round robin or pick first policy. And you can add it in there and it will work. You can also add your own, I don't know, 3 times there, 1 time there. So sky is the limit. Okay, so when it comes to benefits of the gRPC, well, performance, size, due to the fact that gRPC is binary, in some cases, you can have like smaller payloads, which will make your applications like behave like they are faster. So it also allows you to have polyglot environments. I tested it with Node.js and it works just fine. You have the same protocol buffers file, you compile it for different languages, and you can consume those from different languages. So due to the fact that it's small, the payload, it will have low network usage. It's perfect for point-to-point communication. So if you know where the downstream API is, and you can configure that to be a gRPC service. It's contract, smaller payloads, faster because HTTP2. It has these streaming types that might become handy if you have the right scenario. And with .NET 6, it can be configured to run with HTTP 3. So if HTTP 2 is not enough, now we have 3. So the downsides of gRPC is that you'll still have temporal coupling. So you'll still need the server to be up in order to get data from it. So another thing is that you might forget that there's network involved and you might abuse that. It wasn't human readable, but now every single tool that allows you to test APIs will allow you to work with gRPC, including Postman, and they're very nice with those. You'll need to focus on CI/CD, and you'll need to do better testing. And another drawback is that you have only HTTP post, since no caching, and the caching part you'll need to cover by implementing a different thing. So it cannot be by simply adding a header inside the response that, hey, mark this as a cacheable resource, keep it there. Whenever you're getting back to me, I'm going to tell you, hey, you have it already. You cannot do that. So another thing is that you should, and that's the best practice, to have a single point of truth, okay? The protocol file, and you shouldn't like scatter them all over the place, okay? When and why gRPC? So gRPC, give it a try. It's suitable for scenarios where you only consume your API from inside your system. You don't want to expose it. So why not give this a try? There are a ton of solutions that work in production with gRPC. Now, Azure supports it. I tested the other day. I have a blog post in draft around this, hosting it in Azure. So it will replace gracefully those HTTP clients that get carried around. It kind of decouples code, kind of. And when I say kind of, I'm referring to the fact that you won't have those code references, but you'll still have the protocol file. There are things that you can use, like if you already have an application and you want to move it to use gRPC, you can use code first gRPC, which is a concept that helps you like transition to gRPC. I have also a blog post written about it. It's very straightforward. You don't need to have any knowledge about an existing gRPC service. Use that, and you'll be able to consume data from the gRPC service. Keep in mind that distributed systems are all about trade-offs. So you cannot have the perfect technology that helps you implement your technology. So pick the right tools for the right problems. Next steps, have a look at gRPC Web, which is a different technology than gRPC. It has gRPC name, but it's meant to work in the browser. Protocol types, GitHub, Postman was in beta, but now Bloom RPC is dead. And if you're transitioning from WCF, these are some good books to have a look at. Thanks for listening. And for being there, listening to me tonight. If you have questions, I'm here.